Before we start writing the code for a parser, before actually creating the abstract syntax tree, uh, like I showed you, the code crafters tell you to bring in the code from chapter 5 of this book, right? They tell you to bring in the AST printer class from that book into your code from right here. So you can go through it, read the code, and implement it on, read the book and implement it on yourself. But I'll be doing that in this video. We'll be doing everything from scratch. So we will be writing the AST printer as well. We will not be copy pasting the code from their repo to our, because I've made quite a few changes. Uh, so that's why I would like to write the AST printer as well on our own. Anyways, the AST printer in that book uses something known as a visitor pattern, all right, which is a behavioral design pattern. So I thought let's make a video on explaining what the visitor pattern is and show it to you through a very contrived example. But anyways, so the visitor pattern, it allows us to separate the functionality away from the objects on which they operate. All right. So for example, if we have two animals, a dog and a cat, and we have two classes, a dog and a cat. So the visitor pattern would allow you to abstract away or separate the functionality away from those classes. Like both of those animals make noise, both of them mark their territories. So we can abstract it away from the concrete class using this design pattern. So why do we need it? So the theoretical, the answer, the mugged up answer is that keeping behavior along with the object, it breaks solid principles. But why is that actually bad? The problem is that we have four classes, right? Let me show them to you. We have some classes, binary, grouping, unary, and literal. So these classes, we only have four for now. And all of these need to be printed differently. If you go through what they ask of us, unary operators and binary operators are printed differently. Right here, what we are doing is, let me show you, let us actually read. In the previous stages, the tester used the tokenize command. Now we need to implement the parse command. The parse command accepts the part to a file, and if in the file you have 2 plus 3, it returns the following. All right. So if the test.logs file has true, it prints true. And if it has none, it prints nil. All right. And for unary operators, if we have this in the test.logs files, it prints this. And the arithmetic operator, which are all the binary operators, if you have this in the file, this is printed out. So you see, the unary and the binary operators are treated differently. So all of these classes that I showed you, these four classes that we have, they need different behavior attached to them. And that's what we will use visitor pattern for. All of these need to be printed differently. And at first glance, it's easy enough to put a print method in these classes. We can put a print method in grouping, in binary, in literal, and unary. All right. Matter of fact, since they all extend the same abstract class, the expression class, we can put the abstract method in here in the base class, and we can force all the child classes to implement it. So here we are breaking the solid principles. Our classes no longer have a single responsibility. They also, they have a responsibility of being a domain object. They are representing our domain, but they are also representing something. They also have another responsibility, which is printing the data out to the user. All right. So that is one way they are breaking solid principles. In case we want to do something other than printing, like evaluation, and that makes us open for modification, right? So if later in the future we need to add more functionality, we are not close to modification. We are not open to extension. We are open to modification in that case. So that is again breaking solid principles. So in case we want to make changes to the format of the objects in which they are printed. And in that case also, we need to update the existing classes. So if I were to force a print method right here, and in the future the format of the print changes, then I would need to come here and update all these classes, which is not ideal. But that still doesn't tell us why breaking solid principles is bad, right? It gives us a high level view like I will have to come to these classes and update, but why is that bad? The issue actually arises when we bring in new features. Right now we only have four classes. In the future, like we have four expressions, but in the future we may have many more. In that case, all those classes will need to implement the print method, and the logic of printing will be scattered across those tens and hundreds of classes, and there would no longer be locality of behavior. If somebody wanted to update the printing contract the way the logic is being printed, we would need to go to hundreds of classes and update it instead of just updating a single class. It's a developer experience thing. It's not really something that affects the software, I would say. It's just about developer experience. So if you are the only person working on this project and you definitely know that the print is in these expression classes, you don't need to, find where the print method is implemented. You know that. All right. So it wouldn't be an issue. But if it's a large project, in that case it's an issue. In that case we typically cluster related logic together in different classes. So that's what visitor pattern allows us to do. And the other issue is that right now we only have one behavior, that is printing. In the future we will add other behaviors as well, like evaluation, which we are going to in this project, and resolution and interpreting. In that case we will need to add abstract method to our base classes, which is this expression class. We'll need to add abstract methods here, which is something that could be considered good practice because now we are forcing all these classes to implement it, which is somewhat a good practice in a kind of a domain driven sense, where the domain objects encapsulate the domain logic in themselves. In that case as well, we typically create an aggregator class. In typical domain driven design, we create an aggregator class and we have logic in that aggregator class, and the domain objects typically remain quite simple. All right. The issue at hand, when we add a new type of object to our domain, when we add a new expression to our domain, is we need to implement methods that may be required way down the pipeline and not right now. So if my expression had three abstract methods here, one for printing, one for evaluation, one for resolution. So if I were to add a new expression, we would need to implement all those three methods. But right now, I do not have a plan for evaluation and resolution. I'm just I'm adding a new feature to my language. All right. So in that case, I don't want to think about those things that will come down in the pipeline, that will be later in the evaluation or the resolution stage. Right now, I only want an expression, and I want to be able to print that expression. Why should I be forced to implement the evaluation and the resolution methods? That's not ideal. All right. But if our base class has it, any new expression will have to implement it, even though I have not decided how to parse it yet. We haven't even decided how to parse it. Why should I decide how to evaluate it? So if it is something that can be parsed, only then will I make a plan on evaluation. If it cannot even be parsed correctly, if I think of adding a new feature and I am not able to come to a plan of how it should be parsed even, why am I making plans down the line of how it should be evaluated? That doesn't make sense to me, at least. And the other side of the coin is that we want to add new functionality. And in that case, I will have to add a new method in the base class and update all the existing classes. So any new functionality would require a new method here, and then I will have to go ahead and update all the classes that are there in this expression package. So the solution to all this rigmarole is the visitor pattern, which is a behavioral design pattern. And let me show that to you with another example of how it works. So let's do that on Replit. All right. So what we will do is, let's just remove this. I created an empty repo on Replit. You can follow along if you want, but I do not recommend. It's just for demonstration purposes. Anyways, so what I'll do is I will create a class and I'll call it animal. And in here, this is going to be an abstract class. All right. Oh, animal.java. It should animal.java. So that's my abstract class. And let me add two more classes. So one is going to be a cat.java and the other is going to be a dog.java. All right. So dog.java is going to be extending the animal class, and similarly the cat class is going to be extending the animal class. So like that. So if we want to add a common functionality to these, what I'm saying is the easiest way to do that is add an abstract method right here. All right. And then I can let me change the name, make noise. And now in the dog class, what I can do is I can create this method, right? Dot out dot println. All right. So this is the most easy way of doing it. It's the easiest way of doing it, but it has issues. All right. And that's what I'm trying to explain in this video. If we were to add new functionality, then now I need to add a new abstract method right here. Let's call it mark territory, right? And with this, I would need to implement those methods right here, like so. So a dog marks the territory by pissing around it, and let's say a cat marks the territory by making noise thrice. Those are the logic for marking territory and making noise for dog and cat respectively. All right. So, and if I were to add a new animal, uh, if I were to create a new animal, let's say I'm God, I'm creating a new animal, but that animal cannot mark territory. It's not evolved enough to do it yet. So in that case, I would still need to implement the mark territory method because it will be extending the animal class. So I will need to have some implementation of mark territory. Maybe it throws an error, but why should I do that? Why should an animal that does not mark territory should have this method in it? Maybe it will never evolve enough to mark territory. Maybe it never evolves enough to mark territory. So why should it have this method in it? It should not. That is one issue. And let's say I'm God and I created a new animal and it's going to mark territory just like a cat would by making noise 3 times. But I have not even decided what kind of noise it's going to make. So a new animal that marks the territory just like a cat would, but I have not decided what kind of noise it's going to make. I have not decided this implementation yet. In that case, I'm again being forced to implement this without having even implemented this. This is the first thing in the pipeline. This comes later on. This functionality comes later on. So why am I being forced? I should be able to make this decision independently of this decision. But if I were to keep these methods here, I'm not allowed to do that. All right. So right now, I only want an animal that can make noise, but the current setup does not allow it. It will mark territory later on, so I mark the method as not implemented yet. In that case, I will need to update all such animals, right? If there were like 10 animals, that will mark territory later on, but not now. I will throw some error in the mark territory method, and then I will need to come later on and update those methods. That doesn't seem right to me, at least. The solution is to separate this behavior away from the animal. The solution is to separate these methods out from these classes. All right. And this can be done by the visitor pattern. So what we'll do is we will create an animal visitor class and we will give it the animal object. We will create a class and we will send it objects of dog and cat, and it will it will do the required logic according to what object it has been passed. If it has been passed a cat object, it will invoke the cat's make noise, and if it's passed the dog object, it will invoke the dog's make noise. That's what the visitor pattern does. It will make different kinds of noises on different animals and mark territory differently by pissing around or meowing thrice for different kinds of animal. So let's do that. Let's implement the visitor pattern. What I'll do is I will create an interface and I will call it animal visitor. It's a generic interface. It will not have anything like right now. This is you'll see what I mean by generic when we implement that in our interpreter, why the generics help here. But in this example, let's not think about generic. Anyways, this is just going to be a public interface, animal visitor. All right. And in here, I'm going to have two methods: void visit cat and void visit dog. All right. And if I were to add a new animal, I would need to add the visit method for that animal right here. Okay. But if my animal is not allowed to do some visiting, then I don't add the visit method right here. That's what is very convenient. If my animal is not evolved enough to do functionalities, if it's a single cell organism, then I don't add a method to visit right here. We do not allow visiting that animal. Anyways, we already have an animal class, but let's update it. I will create another method and it's going to be, I'll call it uh, accept, and it's just going to be an animal visitor, and I'll remove these. So now my abstract class only needs this one method. Okay. And I can remove this logic from here. I can remove this logic from here. And in these classes, as they are extending the animal class, they just need this method, right? They just need to override this method. So public void accept, and it's going to take an animal visitor. And we're going to call the visit method with the current object. That's all. Similarly, in cat, this thing remains the same. This doesn't change. So it takes an animal visitor and it visits that interface, that class, that concrete implementation of this visitor interface by passing the current object to it. All right. So now what I'm allowed to do is I can create concrete implementations of this visitor. So add a file. Let's call it noise visitor. All right. Dot Java, and it's a public uh, class. Let's call it noise visitor, and it implements the animal visitor. All right. And in here, I need to override those two methods. This is one method, and this is the other method, and I'm going to change the logic right here. No, this is fine. Shout meow and woof. Right. So that's how these animals make noise, but I need to override these methods, right? So let's do that. At the rate override. And this, I just need one more method, one helper method here. Public void visit, I'll call it visit animal. It takes an animal and it calls the accept method with this class on it. All right. So that is my noise visitor. So now in my main class, what I can do is I can create an object of new noise visitor, and I can create an object of cat, and I can create an object of uh, and dog. And now if I want the dog to make the noise, what I can do is I can call noise visitor dot visit animal, and I can pass in the cat or I can pass in the dog. So that should call the respective methods. Let me show you the control flow. I pass a cat object to the visit animal method. Control comes here. We call the accept method on the passed in animal. I passed in an object of cat, and to the cat, and in the cat, I call the accept method. All right, so I go to the cat and I call the accept method, and I pass in the current object, which is the noise visitor. So in the cat object, I get the visitor, which is this visitor is going to be a noise visitor. And then I call visitor.visit with this. Now this object is a cat. Because it's a cat, it does dynamic polymorphism, and this method is called. Because we know based on the in input parameters that this method will be called and meow should be printed. So let's try to run it. Yeah, you see, I get meow and then I get woof. So in my main class, meow was printed for the cat and woof was printed for the dog. So with this, my cat and dog objects are quite lean. My dog and cat objects are very lean. This can have fields if you want. It can have private, final, uh, int legs equal to 4 or something like that. It can have fields, but it won't have functionality in it. All right. The functionality will be abstracted away in a class, which will be a visitor class, this noise visitor. And if we want to add a new functionality like marking territory, so what I can do is I can create a new visitor. I can create a territory visitor. I can create a territory visitor dot Java, and in my noise visitor, let me just copy this in my territory visitor, public class territory visitor. Let me paste this, and it's going to visit animal, and it's going to visit uh, by meowing thrice. All right, and it's going to mark territory by pacing around. All right, let's go to the main class, and instead of noise visitor, I'll call the territory visitor, and here I can call it animal visitor. Animal visitor, and I can call the animal visitor on the dog, and this should print pacing around. So let's try to do that. What is the issue? Animal visitor dot visit. Oh, sorry, because it does not have that. Yeah. So the dog paces around to mark the territory. So it's quite easy to extend functionality, to extend the classes, and it's quite easy to add functionality. For any functionality that we want to add, we just create a new visitor class. All right. And for any new domain object that we add to our project, like a cat or a dog, if you were to add a mouse, we would create a mouse and we would add a visit method for that right here. All right. Now, if there is some functionality that only cat and dogs are allowed to do, and a mouse is not allowed to do, then we don't add the mouse right here. And if there is some functionality that all three are allowed to do, like existing, so we will create a new interface for it that will be common for all the animals. All right. We'll create a new interface. Let me show that to you what I mean. Uh, Add a file. Let's say it's a common functionality for all animals dot java. So what I'll do is I will create a public interface, public uh, interface, and it is common functionality. So let's say that I right now I only have dog and cat. Let me add a mouse as well. Add file mouse.java. Mouse.java. Let's say a mouse is not allowed to mark territory and make noise. All right. Let's say a mouse is only allowed to public class mouse extends animal. All right. Uh, let's say a mouse. What's there in the animal? It has an apps animal visitor. Hmm. Where is the mouse class? So let me go to the dog class. Let me copy this. Let me go to the mouse class and paste this. Right. So if let's say making noise is a common functionality. Uh, let's say making noise is a common functionality. So what we'll do is common functionality right here, right? So cat, dog, and mouse are allowed to do it. So void visit mouse. All right. And let's remove this from here. And wait, where is common functionality? Yeah. And this is the common functionality. And let's say we have some functionality that only evolved animals are allowed to do. Evolved animal visitor dot java. All right. So in my common functionality, it also extends the animal visitor. All right. Similarly, evolved animal public interface. Evolved animal, it extends the animal, but it doesn't have the so it the mouse is not allowed to do evolved activity, only a dog and a cat is. So dog, and let's make it cat like so. And let's say noise visitor, it does not implement the animal visitor. All the animals are allowed to do it. So let's say it's common functionality. Implements common functionality. And common functionality has a visit mouse method as well. So common functionality noise. So let me create a override of visit mouse, and it makes noise by it makes some noise, right? But marking territory is not a mouse is not allowed to do is not allowed to mark territory. Only evolved animals are allowed to do it. So let's say it's evolved animal visitor. All right. So only a cat and a dog are allowed to do this. See now how easy it is to extend, add new classes. If dog and cat are allowed to do something, and if I want to add a behavior that only a dog and a cat are allowed to do, then for that I implement the evolved animal visitor. And if there is some functionality that all my domain objects are allowed to do, then I implement this common functionality visitor. So now what happens is, let's say I'm God, I create a mouse. So now what I can do is I can decide how a mouse makes noise independent of how it marks its territory, which was not true before. If you were using a single abstract class, in that case, I would have to decide how a mouse marks its territory. I would have to decide that, and I would alongside deciding how it makes noise. But now I'm independent. Now those choices to me are mutually exclusive. I can decide on those independently. So if the mouse may evolve in future to my territory. In that case, I will move it to the evolved animal visitor. But it does not right now, so it stays in the common functionality visitor. Now we no longer have to update the existing cat or dog classes to extend the functionality. All we have to do is create a new class, like we created one for directory visitor, right? And we no longer have to implement the behavior methods in any new animal. So, like for the mouse, we do not have to implement behavior methods before they are allowed to do that behavior. All right. So God can add them to the visitor whenever he feels like it now. So that's what the visitor pattern is. And the next video will be implementing the visitor pattern on all these classes, on these binary and grouping, literal and unary classes. We will be implementing the visitor pattern for these. And what will be the behavior? The behavior will be printing, like how it's like deciding how it's printed to the console. That's what the visitor will do for us. All right. So that's it, and I'll see you in the next one.